we are starting with paper 1, first question. So I just want to make sure you get these logics properly. Okay. So we have this first question. Come on, sir. Consider a large disk of radius capital R and two smaller disks, each of radius smaller, lying on its circumference as shown in the figure. See, this is how it is. We have a disk like this, okay, and there is a smaller disk here, another smaller disk. These two are identical. They're all small r radius only. Yeah, full of them. And this is bigger r radius. They're asking from here, those two, right? The smaller disks are initially in contact, okay, with each other with angular separation of delta theta. This point to this point, this angle was delta theta. Okay. They are made to roll without slipping in opposite directions with constant angular speeds omega and 2 omega as shown in the figure. So this is omega, this is 2 omega, right? While the large disk is held stationary, this they are fixing it, okay? This is fixed disk. They are asking the time taken, time tau, at which the smaller disks are again in contact is the question, right? So they have given 4 options and all.
Yes, sir.
When you saw this one, what went in your mind? What was the logic?
Sir, this is a fairly common question you had given in class.
Okay.
But I was saved by the options.
Okay.
Because I forgot that when it comes here again, we have the same delta theta.
Yes.
And I forgot about it until I saw the options.
Oh, nice. What was running in your mind? Same thing. Yeah. But see, they have. How are you bringing in this rolling motion? This one, like, see, the concept wise, you have learned rolling in a normal flat surface. Here we have a curved surface. How are you bringing that?
So I mean, as long as this, we just consider the center of mass with some other omega dash. Then we observe this omega.
Okay.
Then we just observe this point velocity and use our similar logics. So even though we might not have explicitly done rolling on curved surfaces, it's still doable with whatever we know.
Yes. So don't you think it is similar to having rolling motion on a surface, like a trough, and we have rolling and oscillations in it and all? Like,
yes,
similar to
yes,
it? Yeah? Okay. Anyways, here they are asking us to ignore gravity also. So let's ignore and let's try and solve. And we'll give our viewers also like how to solve this one. Okay? Yeah, let's do it. So everybody, this problem, see, we know this is a disk, let's say. We have this. And as we have learned this, if there is a surface, if this is this smaller disk, if this radius is r, let's say, if it starts rotating with omega with respect to the surface we are observing, that the bottom point, right, which is in contact with this particular bigger disk, that point velocity should be at rest. The point which belongs to the disk, right, it should be at rest. So because of rotation, you will have omega r speed, right? And because of translation, if it has speed v, then the bottommost point will have the speed v because of translation. We know that the bottommost point will have the velocity because we have learned this idea with respect to our logics in relative motion. See, velocity of point P, which is at the bottommost point of the disk, right? That velocity is, with respect to ground frame, is equal to velocity of point P with respect to center, plus velocity of the center. Okay? So velocity with respect to the center would be omega r because of rotation. Because of translation, you have velocity v, right? So bottommost point, if it is at rest, then v should be equal to omega r. Got it? So I think this idea you are familiar, and this we know, we have done this, right? So this point will be going with the speed of omega r, that let me name it as v, and on the same logic, this point will be moving with the speed v dash, and v dash on the same lines, we can write this one as 2 times of omega r. Why 2 times of omega r? Because we have 2 omega speed, the bottommost point will have the speed because of translation v dash, and because of rotation 2 omega r in this way, 2 omega r. So we know that this is moving with v speed, this is moving with v dash speed. So it is more like now we have solved almost this problem. Only thing is we have to bring in a little bit of kinematics and complete it, right? So this particular disk, as it starts rolling and reaching here, let's say since it is moving a bit slower and this is faster, let's say it goes a bit faster and reaches somewhere here. I'm just guessing some location. Alright? And this is also the location of the other disk. Now no matter where they meet, still the angular separation will be there. Angular separation will be delta theta only. Delta theta will be the angular separation, right? If this is the case, then we know that keeping one point at stationary condition, looking at other, sitting at one of the center of this particular sphere and looking at the other one. So we call this one as relative motion, and we keep one body at virtual rest and looking at the another body. And we know that effectively they have to travel a distance. So our logic is distance by time taken would be our speed. That's our general logic, right? I'm just going to observe that the time taken would be distance by speed. Time taken would be distance by speed. Now we work with relative distance and relative speed. The time would be same. Got it? Now using this logic, we have the distance that it has to travel relatively. If you keep one and look at the other, so you know that this has to cover all the way and reach the other one, right? So overall, we have 2 pi radius, effective radius. If it was like really, really small size, we know that the distance would be 2 pi r for entire, circumference. But from this center, if you observe, the radius is effectively r plus smaller, right? So we can write it as 2 pi smaller, okay, capital R plus smaller. This is the effective distance as we consider from this point all the way back to the same point. But there is an angular separation, so meaning there is some separation, right? We'll bring that separation also. And also on top of it, they're saying that delta theta, right, is very small. So sine delta theta is delta theta, which means delta theta is small. If it is small, then you can treat this length, right? It is almost a straight line, but actually you might think, sir, that distance, straight line or curved. You can think like this, a curve, okay, where we have arc length equals radius into plane angle. So we can write 2r equals r plus r times of delta theta. This relation probably you know that arc length is equal to radius into angle with plane angle that we have, right? So here this 2r, right? And in our formula it is a curved line, right? But here you can treat this curved line or straight line are almost same because delta theta is small, right? So using that logic here, we can go ahead and say that here the initial separation was pi times of delta theta. Pi times of delta theta here we have, right? So let me write, not pi times, let me write it as r plus r times of delta theta. See, because from here to here it is r plus r into delta theta is this distance, right? So that's the distance we have. And when it reaches back again, final separation will also be involving the same distance of separation between the centers. So it is 2 times of it. Okay. So this is overall length minus of this. This is the effective relative separation between them. So we got effective relative separation divided by effective speed. So this is moving this way, this is moving the opposite way. The speeds gets added up. So we can write it as v plus v dash. That's the time taken. All we have to do now is to just solve this mathematics. Nothing much. So we can write tau equals 2 pi times say r plus r by 50 that they have given minus 2 times delta theta. Delta theta we can write it as, let me substitute here, r by 50 and r times 1 plus 1 by 50 times of delta theta. So from this we can simplify and say 2 r and r is gone, so 50 gone, so 2 by 51 would be our delta theta. Okay, so 2 by 51, 2 by 51 here, and r plus r, which I'll write it as r plus r by 50. Okay, that whole thing divided by, what do we have here? So v plus v dash. V is omega r, v dash is 2 omega r. So omega r by 50 plus 2 omega r by 50. This is what we have. Now let's simplify this. Tau equals here 2 pi we'll have, so 51, and r we have, so let me write r here, and there is 50 here in the denominator, minus 4 times of, there is 50 here, so let me separate this so that we don't mix up things. Okay, this is how it looks like. Yep. So 4 by 51, and there is 50, let me write 50 here, and there is r here, and 51 by 50. Just checking with the math. 4 times r, 51, 51 here, 50 here, whole thing divided by 3 omega r by 50. Right? This is what we have. So let's simplify this. Okay. Now this 51 and 51 cancelling up. This 50, this 50, and this 50 will cancel up. Right? So we can now write our final answer. Okay. So I will erase a bit of it. So here, this concept we have understood, right? So I'll just take this one out. So we have tau equals 2 pi times of. So we can just simplify that and write 2 pi times 51r. So 2 pi r. Tau equals 2 pi times 51r, right? 51r minus of 4r by 50. 4r, but 50 is already cancelled, right? So 4r divided by 3 omega. So we can just get rid of all this r dependency also, right? And let's look at the options. We need this 51 outside, so let me take 51 outside, and let's have 3 omegas outside, and we'll see what is there inside the bracket. So 2 pi will be there, and 3 omega I have taken outside, 51 I have taken outside, so 2 pi minus of, so I think we have here, so one of the term 51 by 50. So when we take 51 outside, right, we are taking 51 outside, so I multiply by 51 here, divide by 51, okay? So I am taking 51 outside, so 2 pi we have here, minus of 4 by 51. So we are just checking out the options again. 51 by 3 omega, 2 pi minus 4 by 51. So we got bunch of other options also, right? I think this is very simple enough. I think you can easily observe that it is option C, and that's our answer.
We will discuss question number 1, question number 2, paper 1. First we read the question. Consider a circuit consisting of a capacitor of capacitance C and a coil with n turns per unit length. Cross section area S and length D, where D square must greater than S. There is another coil of length D by 2, cross section area S by 2, and 2 n turns per unit length completely inside the larger coil, as shown in figure. The ends of the smaller coil are connected with each other by an insulated conducting wire. The self-inductance of larger coil is L. Neglecting as effects and all the ohmic resistances, the resonant frequency of the circuit is. One coil is this one, and other coil inside this. Other coil is inside this, and it is short circuited, and it is capacitor, and this is a source, AC source. First, we see this, concentrate on this part. Suppose 2 coils like this. Current in this one is I1 and this is I2. If we see about bigger coil, its inductance L1 is mu naught n square area cross section area S into D. It is for bigger coil. For shorter coil, and it is given to L in the question. Mu naught 2n square, S is S by 2, D is D by 2. So it is also equal to L. So both coils have self-inductance L, right? Now, second step. In the second case, ABC in the smaller coil, magnetic field due to only bigger coil. So if we find mutual inductance, M is equal to magnetic field due to this is mu naught Ni 1. It is magnetic field into its area is S by 2 and number of turns is 2n into D by 2 divided by current I1. And from this we got L by 2. It is second step. Now, third step. A smaller coil is short circuited like this one. So induced EMF, net induced EMF should be 0. So L di2 by dt minus M di1 by dt is equal to 0. Is equal to 0. Here M is L by 2. So you write di2 by dt is equal to L by 2 di1 by dt. So I2 is equal to I1 by 2. Now we find in the next step equivalent inductance for first coil like this one. L equivalent di by dt is equal to L di1 by dt minus M di2 by dt. This is equal to L di1 by dt minus L by 4 di1 by dt. So here we got L equivalent is 3L by 4. So omega is 1 upon root LC, L equivalent into C, that is L equivalent 3L by 4, 3LC, and this one. In this step, second coil is not connected to first coil. When for equivalent we consider only L di1 by dt minus M di2 by dt. It is the answer. We discuss question number 3 in paper 1. First you read the question. A solid cylinder of radius r rolls without slipping with a center of mass speed v0 to gr by 3 on a horizontal surface with a vertical edge as shown in figure. Here g is acceleration due to gravity at the moment when the cylinder loses contact with the surface of the rotation around the corner. The speed of center of mass is. Now I explain the solution. Just see. It is a surface and this cylinder is rolling with velocity v0, suppose like this one. And the end, when it reaches at this point, its center is here. Like this. But here surface end, so it starts toppling about this. When it starts toppling about this, then suppose at this moment it loses the contact and its center is, suppose this one, initial center is here. Suppose this angle is theta and at this point velocity is v0 and at this point velocity is v. Till this instant rolling continue and we apply law of conservation of energy. So loss in potential energy mgr 1 minus cos theta is equal to kinetic energy of cylinder is half mv naught square plus half I omega square. So half mr square, omega is v square by r square. That is equal to 3 by 4 mv square. Here we know. So we write here 3 by 4 mv square minus v naught square. Right? This loss in potential energy is equal to gain in kinetic energy. At this point, contact breadth. So n becomes 0. Here mg. This angle is theta. So this angle is theta. mg cos theta. At this instant, provides centripetal force because up to this instant, center of mass moving on the circle. mg cos theta is equal to mv square by r. And after solving these two equations, you got cos theta is 5 by 7 and v is equal to root 5 by 7 gr. So it is the answer.
Question number 4. A double convex lens made up of glass of refractive index 1.5, lens refractive index 1.5 and radius of curvature 20 centimeter each. So it's a double convex lens immersed in liquid of refractive index NL. Correct plot showing the variation of power in the units of diopter. How to find power in diopter as a function of NL. So to finally get a graph of power versus NL. So here we can just use lens maker's formula 1 by f equals mu of lens by surroundings minus 1 into 1 by r1 minus 1 by r2. This is the formula, lens maker's formula, and 1 by f is power. So I'll just substitute the given values in the equation and we'll get the equation for power. So power is refractive index of lens is given as 1.5 by surrounding is NL minus 1 into 1 by R1. For double convex lens, R1 will be positive, that is given as 20, 1 by 20. I'll convert that to meters so that I'll get the power in diopters, SI unit. So I have to substitute radius in the meters. 1 by 0.2 minus of minus 1 by 0.2. Here for second, for R1, right side positive, R2 will be negative. So here minus will come. You just simplify this, 1.5 by NL minus 1, 2 by 0.2, that is 1.5 by NL minus 1 into 10. Now I'll just substitute. If you see the graphs, NL value starts with 1. Right here.
Yes.
NL value if I take as 1, then power I am getting from this equation. NL value if it is 1, 1.5 by 1, that is 0.5, sorry 1.5 minus 1 will be 0.5 into 10, 5 will come. For if NL equals 1, power I am getting 5. Then if we substitute NL as 1.5 by 1.5, that is 1, 1 minus 1, 0, power will get 0. And we substitute NL as 2, 1.5 by 2 minus 1 into 10, that is 0.75 minus 1 into 10, that is minus 2.5 will come. So if you look at the graph now, it should start with 5, then 0, then minus 2.5. So if you look at the graph options, A option is matching. Okay, B also is similar, But what is the difference? In B, they are given a straight line. And we know from this equation, P is not directly proportional to NL. NL is in the denominator. Therefore, you will not get a straight line. So only possibility is A curved graph like this with starting value 5 when NL is 0, 5, when NL is 1.5, power is 0, and when NL is 2, power is negative. So option A is only matching.